Hello again, welcome to this session. Well, actually, in the previous session, what happened was there was a small technical glitch. I could not run the video. I could not run the video in the PPT. So, as a stopgap arrangement, you please type this Toyota Lexus crash string in the YouTube, and you will see all the below thumbnails. Actually, in this video, you will clearly see why, because of a small electronic glitch, four people ended up dead. Because of some electronics glitch, the pedal got stuck, the vehicle started traveling at 120 mile per hour, and despite the best efforts of the driver to stop the vehicle, he could not stop. And even more noteworthy thing is, driver himself was a cop, he was a policeman, and despite his calling his colleagues to help, despite his whatever his prowess is, he could not save his entire family. The people who died was he himself, the policeman, and his wife, and his brother-in-law, and his daughter. So it ended up a real tragic for the entire family. Okay, so in my previous video, I mentioned what is the price of failure in electronics and electrical and electronics. So the price can be life itself. So in case there is some technical error in the electrical and electronics, it can lead to the death of the passenger. That's the reason why all the OEMs are putting so much emphasis and so much significance on ISO 26262. Now, as I said, I'll be briefly touching about the history. As I said, the history is a very boring thing. Let's not dwell much into it. You can just see from this slide that every vertical, like railways or nuclear energy or industrial machinery or medical equipment or robots or electrical control motors, they have their own specific corresponding safety standards. And the first safety standard which was common for all these verticals was IEC 61508, which was established in 2000. And slowly this particular standard IEC 61508 started bifurcating or apportioning to the various verticals. Okay, and finally it got distributed to ISO 26262 for all the road vehicles. And as it is mentioned, it is published in November 2011, and ISO 26262 for road vehicles was developed based on IEC 61508. Now, let's briefly touch upon what is this ISO 26262 in the context of V model. Now, I am speaking assuming that everybody who is watching this video knows what a V model is. But anyway, let me briefly touch upon what is V model. V model is a standard development model for software. All software development life cycle. I mean, when I say software, okay, so software also can be developed like this. The entire functionality of a ADAS can be developed like this. The entire feature of a ADAS can be developed like this. So as you can see on the left side, it is more of the design development. On the right side of the V, it is totally verification and validation. Okay, actually the V model itself is inherently a huge topic, and if I discuss this particular V model elaborately, that itself is going to take more than 1 hour. So let me briefly touch upon the fact that V model is a standard development model for the software. Software development life cycle is based on the V model. And in this development life cycle, as you can see on the left side, all these items, item functions, safety goals, distributed functions, functional blocks, headings, component functions, all these things are subsets of functional safety. All these things are functions of subsets of functional safety, and these subset fall on the left side of the V model. Okay, so this is where exactly the ISO 26262 comes into picture in the entire development life cycle. On the right side also you can see some tests as per functional release and step, and also functional release. This comes into the picture when you are talking about the final safety case work product. When you have to finally submit the safety case work product, I'll be discussing what is meant by safety case elaborately in the coming slides. So when you have to finally submit a work product or an argument that all the ISO 26262 requirements are met, or all ISO 262 requirements are completed, okay, then these tests come into picture. Only if the component passes all these tests, then a work product that ISO 26262 is completed is submitted. Okay, and this falls in the right side of the V model. In this previous slide, as you can see, there is a separate section adaptation of ISO 26262 for motorcycles on the left side. Okay, so development of ISO 262 functionality for motorcycle is totally a different vertical. Even though there is a massive overlap, there are some specific development aspects which are very specific to motorcycles. Okay, now let me push forward. Yeah, what is the scope of ISO 26262? As I said, ISO 26262 is strictly meant for electric and electronic devices, and I think that is clear for everybody by now. And electric and electronic devices consist of both hardware and software. Parts or systems that may significantly impact on human lives in case of malfunction, failure are considered. And equipment that consists only of machinery is out of its scope. For example, as I mentioned in the previous slide, trailer where only the container of the goods is mentioned, that is left out of its scope. And the entire life cycle of the automotive products, ISO 26262 should be applicable or should hold good for the entire life cycle of the automotive products. Motor vehicles up to 3500 kg. Motor vehicles up to 3500 kgs fall under the scope of ISO 26262. And the entire life cycle of automotive products, as I said, there's a small repetition here, right from the commissioning to the point where the vehicle is totally scrapped. After the life of the vehicle, the entire life cycle ISO 26262 holds good. Or in other words, the functional safety of the vehicle must be developed keeping the entire life cycle of the automotive product, right from it selling at the dealership to the point where the vehicle is scrapped. ISO 262 to focus on the functional safety of electric and electronic systems in the vehicles. Okay, so this also I would like to mention that ISO 26262 is applicable to the electrical vehicles also. And functional safety in accordance to the ISO 26262 affects all systems containing electrical, electronic and electromechanical components, that is systems from fields of actuator, sensor technology as well as control electronics. Now when you say electronics, what all comprise of electronics? Right from the sensors to ECU to the electromechanical components like actuators, like steering or electronic braking, electronic door, electronic body, all these things are falling under the scope of ISO 262. So in case you see even electronic digitally controlling of the rear view mirror, I'm sure everybody who has a car has digitally controlled electronic mirror. I mean, just by controlling a small knob, you can control the position of the rear view mirror or side view mirrors. Even that is having electronics aspect in it. Even that falls under the scope of ISO 26262. Now, the framework provided by ISO 26262 deals with the functional safety of products, processes. Now, what is meant by product? Usually, the product, it conjures up the image of hardware. Maybe the hardware means, when I'm talking about the hardware, I'm talking about electronic control unit minus the software. Electronic control unit, which comprises of the chip, the program memory, the erasable memory, all these things fall under the hardware of the electronic control unit. The standard requires a safety case and a number of confirmation measures to be applied during the product life cycle. So for the entire life cycle of the hardware, I'm talking about a single chip, the metal part, the silicon part, the substrate part, all these things fall under the products. So this entire product falls under the category of the ISO 26262, and it has to be taken care that the entire product is developed keeping ISO 26262 in picture or in the view. And one more important category which is subset of ISO 26262 is process. The standard requires specific life cycle processes to be implemented within a safety management system driven by risk-based approach. Okay, so what is the risk-based approach? I mean, we will be discussing about the risk analysis, hazard analysis, and risk assessment in the coming slides. So right now, you keep in mind that even processes, the development processes, are important aspects of development, important aspects of ISO 26262. Let me read what is mentioned here. The standard requires specific lifecycle process to be implemented within a safety management approach driven by a risk-based approach. So when you take care of the process, it must be, you must be sure that the risk which is posed is always reasonable. In one of the first definition, I mentioned that ISO 26262 deals with unreasonable risks. Now coming here to this particular slide, processes should always pose reasonable risk which can be dealt with. Now one more important point which I want all of you to understand is Fusa has more than 750 requirements. The functional safety has more than 150 requirements comprising of requirements for the hardware and the software. Usually, I mean, this is a ballpark figure, this is not accurate figure. This is approximately 750 requirements including the OEM and supplier requirements. Because OEM may have some functional safety requirements, supplier tier 1 may have some functional safety requirements. All these things put together, it may come up to sum up to 750 requirements.